So today we're going to be going over extraneous solutions. Now, the whole concept of what an extraneous solution is that we're going to get answers for these questions, and then when we plug them back in, they're not going to work. Extraneous values are typically called false positives. The most common way that we're going to see them throughout this particular course over the next few sections is going to be when we encounter absolute values. Absolute values indicate that we need to go in a leftward and right direction on the number line. And sometimes one of the directions or both the directions just don't work out very well. So we're going to go ahead and say, okay, well, what exactly does that look like? And I think the best way to do that is to jump into number one. So let's take a look at this one. As of right now, we see that our absolute value brackets has already been isolated, which means we can immediately jump into our leftward direction, which is our negative, and our rightward direction, which is our positive for the absolute value. This is going to tell us that I'm going to take my 9x, and I'm going to set my 9x equal to the leftward direction of negative 45. So negative 45 set in the leftward direction is a negative 45, or in this case, a positive 45. The rightward direction means I'm going to take the negative 45 and just keep going in that general direction, which is a negative 45. Perfect. So now that I have my two equations, what I'm going to do, let's do this in green. So I'm going to check my work, which means I'm going to divide both sides by 9 to get rid of that coefficient. I get x equals 5 over here. There's number 1. And if I go over here, I'm going to divide both of these sides by 9, which is going to leave me with an x equals negative 5. There's answer number 2. So as of right now, we've done our work, we've done the proper steps, and we've gotten two separate answers. It looks like an answer, it sounds like an answer. We're going to check to see, does it work like an answer? So we're going to take our answer and we're going to plug it back into the original question, which means I'm going to plug this 5 back into here and see, does it hold water? Does it work as we expected it to? So let's do that. So I take the absolute value of 9 equals negative 45. Absolute value of 9 equals negative 45. And I'm going to plug this value in. So I'm going to plug that 5 in. I'm going to plug this negative 5 in. And so I'm going to see, do these answers work out? And let's see. So 9 times 45 is going to be the absolute value of 45. It's negative 45. And if I take the absolute value, I get positive 45 equals negative 45. Well, we know this does not work. This is false, which means that my answer up here is an extraneous solution. It doesn't actually work. It looked like it should, but when we tried it out, it didn't work out. Let's try the other one. This gives us the absolute value of negative 45 equals negative 45. Looks good so far. But when we take that absolute value bracket, we know that negative becomes a positive. And again, we get another false statement, which means that this answer doesn't work either. So unfortunately for this, we have no solutions. Perfect. So I've got no solutions for this. It looks like I could have had two, but neither one of them when I plug them back in works. So as we said, it looks like an answer, it sounds like an answer, but does it work like an answer? No, neither of these did. There's no solutions for that problem. And so let's take a look at number 3. Now with number 3, we're going to walk through this the same way we just did, but I want you to take a pause and I want you to look at this and see if you can spot what we can state about this particular question where we don't actually need to do any work. Is there a way we can skip everything? You might come up with a few different solutions, but let's go ahead and let's work this one out and see at the end what could we have done to save ourselves some time. So in this one, my absolute value bracket is isolated, so I'm going to go ahead and I'm going to split it into my rightward and my leftward directions, which means I'm going to take this n plus 13 and set both sides n plus 13 equals. And I'm going to take this number right here, negative 65, and multiply it times a negative 1, which is going to give me a positive 65. Over here, I move in the rightward direction, which means I multiply it times a positive 1, which is just the same old negative 65. Perfect. And then I go through and I solve these. And so for both of them, I subtract 13. Over here I subtract 13, and I'm left with n is equal to, let's see, that's going to be 52, answer number 1. And when I subtract 13 over here, that's going to turn into n is equal to negative 78, answer number 2. So again, looks like an answer, sounds like an answer, but let's go ahead and let's plug it in and see if it works like an answer. So I'm going to take this and say plus 13 is equal to negative 65. Plus 13 is equal to negative 65. I'm going to plug the 52 in, and I'm going to plug the negative 78 in. And again, yes, we are taking this and we're plugging it back into the original equation. Let's see what we get. 52 plus 13, that is 65. 65 equals negative 65. That is false, which means that answer doesn't work. My next option right here, negative 65. Oh, don't forget my negative sign. Positive does not equal negative, so again, false. So for this one, the answer is, again, unfortunately, no solutions. Perfect. Okay, so now that we got a good idea of what's going on there, what could we have done in the beginning to skip all of this and just said, there's not going to be any solutions? Well, what you could have noticed is that our absolute value bracket is set equal to a negative number. And ask yourself the question, when I take the absolute value of any given input, does it produce a negative output? And the answer is no. So it doesn't matter what work we do, the answer, whatever we plug into here, will not give us a negative answer. So what we could have done is we could have gone straight from here and said, hey, absolute value will never produce a negative output, and led that into the no solutions. So you could have skipped all of this if you said, hey, I'm looking at this setup here, and that is going to give me a positive. When will I ever get a negative? Well, never. So we can't just willy-nilly go ahead and say there's no solutions. We got to give a reason why. So we can either show the work, or if we know the shortcut, we can state the reason why we can use that shortcut. Perfect. And so if we look at the next one, number 5, you might be tempted to use that exact logic and say, well, hey, the absolute value will never give us a negative number. But pause for a second. Is the absolute value bracket isolated right here? And the answer is no, it's not quite isolated just yet. So what I've got to do is I have to add the 15, which in fact cancels that out over there. And I'm left with the absolute value of y minus 4 is equal to 10. And now if we ask ourselves the same question, the absolute value bracket can in fact produce a positive result. So I do need to show my work and see if both those answers work out. So let's go ahead and try this. I'm gonna take my leftward and my rightward direction, which means I'm taking this number right here, multiplying it times a negative 1 and a positive 1, and see what we get. In both cases, I'm going to take the y minus 4 equals, y minus 4 equals 10 times negative 1 is negative 10. 10 times positive 1 is just positive 10. Perfect. Over here, I'll add 4. In effect, cancels that out over there. And I'll get my first possible answer of negative 6. If I work this answer over here and I add my 4, that in effect cancels that out. I'll get my second possible answer of y equals 14. Perfect. Now comes the last step, where I take my possible solutions and I plug them back into the original question. And I say, okay, something minus 4 minus 15 is equal to negative 5. Something minus 4 minus 15 is equal to negative 5. I'm going to plug in the negative 6 and I'm going to plug in the 14 and see what we get. Let's get this up just a little higher. So negative 6 minus 4 is going to give us negative 10. Absolute value of negative 10 is positive 10. 10 minus 15 is negative 5. That is a true statement right there, so that does include that as part of my answer. I'm looking at this one right here. The absolute value of 10 minus 15 is negative 5. Absolute value of 10, which gives me negative 5, equals negative 5. That is also true, which means that is also validated as part of my solution set. So when I write out my final answer, I say that right here, y is equal to, let's see, negative 6, comma 14. I get both of them right there. Perfect. And so that's going to bring us to a few other questions. So when I look at this next one, what I'm seeing is the fact that I have a variable both inside and outside the absolute value brackets. I have the absolute value of 2x, and I have an x on the inside as well. So how do I do that? Well, I did the exact same thing I did before. I check to see, are the brackets isolated? If so, I take the left and the rightward direction of what's going on here, which means I'm going to take this, multiply it times a negative 1 and a positive 1, and just keep moving as though that is a number. Remember, we know a variable is just some unknown number, so we treat it the same way we would treat a number itself. So x times negative 1 becomes negative x. X times positive 1 is just x. Perfect. So to solve this one over here, I'll add my x, which in effect moves, it gets rid of the x on the right, and over here on the left, I get 3x is equal to 0. I have one last step. I'm going to divide by 3, which gives me a possible answer of x equals 0. That's going to be the first number I check out. The second number over here, well, I get rid of the x on the right, which means I need to do the same thing to the left of the equation. So I get x equals, ooh, fancy. I get 0 twice. So when I perform my check step, specifically in this one, if I check 0 over here, am I going to get the same result if I check 0 over here? And the answer is yes. So I only need to check one of these. I don't need to check 2 because it's the same answer. So I'm going to copy down my original question. So 2 equals that. And I plug in a 0 here and a 0 there, and I just see what I get. So the absolute value of 2 times 0, that's the absolute value of 0, which is 0. That is in fact true. So not only that one, but both of my zeros are deemed as correct solutions. So you have a couple ways that I could write this. Now we could do our tried and true x equals 0, comma 0. Some of you might say, well, how about just x equals 0? And albeit both those are true, I think the best answer at this level where we're wanting to go is let's go ahead and write this. X equals 0 with a multiplicity of 2. Okay. And we're going to see that language pop up again later in the course. Now, it doesn't matter which one of these you give. You can give that top one, you give the middle one, you give the bottom one. I would say that this is probably your first place, your second place, and your third place answers to show whoever is looking at this question, looking at your work, that you know what's going on. I'd start out with this one because, again, we will see this language later on in the course. We're not going to go over that too much. Just know that that's what we're going to see. So having done that, why don't you go ahead and try out number 9. Pause the video, give it a shot, unpause it when you're done, and see how well you did. Okay, so now that you've had a chance to try it, let's go ahead and see how we did. My absolute value brackets are isolated, so I'm going to go ahead and immediately take both the leftward and the rightward directions. So I have 3y equals and 3y equals, and I'm going to take this whole thing and multiply it times a negative 1. So y and 16 both get multiplied by a negative 1. That gives me a negative y and a negative 16. Over here, they're both multiplied by a positive 1, which leaves me with y plus 16. You know, so they both change signs, or neither of them change signs. Keep that in mind as we move forward throughout the next few problems. But solving it, same exact way. I get my y's all on the same side by getting rid of whatever's on one side. I'm going to get rid of the y on this side. Effectively cancels that out, and I'm left with 4y equals negative 16. To get rid of that coefficient, I divide by 4, which leaves me with a y is equal to negative 4. Answer choice number 1. Answer choice number 2, I subtract a y over here to get rid of this y. That leaves me with a 2y is equal to 16. To get rid of the 2, I divide by 2, which leaves me with a y is equal to 8. Perfect. So now I'm going to take my 2 answers, and what I'm going to do, I'm going to plug them into this right here. So the absolute value of 3 times this number equals that number plus 16. The absolute value of 3 times that number equals that number plus 16. I'm going to try out both the negative 4 and the positive 8. So in this case, I just got to plug them in 2 separate places. Okay. So now that I've done that, I check the left and I check the right and see which one holds up. So I get negative 12 equals negative 4 plus 16 is positive 12. So 12 equals 12. That is in fact validated. That works out. 3 times 8 is 24. 8 plus 16 is 24. 24 equals 24. Both those answers are good. So you should have gotten a y equals negative 4 and comma 8. How well did you do? And so that's going to bring us to the last question. Very similar style question we've got right here. Now notice I have a positive 3n and a negative 24. So when you're working on this one, keep in mind when we take that left and rightward direction, what that might imply. And so go ahead, pause the video, unpause it when you're done, and see how well you can knock out number 11. Give it a shot. Okay. So now that you've had a shot to try it out, we know that go ahead and we're going to split this into a leftward and rightward direction. And remember, we said pay close attention to what happens when I multiply this whole side, because I have both a positive 3n and a negative 24. When I multiply that times my negative 1, the 3n turns negative. But the 24 was already negative, so when I take the 24 and multiply it by a negative, that turns positive. Oftentimes what we'll see students do is they'll either make them both negative and make them both positive, and they're not really considering that we're taking a negative version of this, which means just change the signs. I may get alternating signs, I may not. It just depends. And when I take the positive, I'm not making both of them positive. I'm multiplying them both times positive 1, which keeps their signs. So, as I walk through this, I'm going to add my 3n to get rid of it over here on this right-hand side. That leaves me with 8n is 24. And to get rid of the 8, I go ahead and I divide by 8 because it's connected via multiplication there. And n is equal to 3. Answer choice number 1. If I work this one over here, I get rid of the 3n by subtracting it. And all I'm left with on the left-hand side is 2n. To get rid of that 2, it's connected via multiplication. I go ahead and I divide. That's going to leave me with an n equals negative 12. Answer choice number 2. Perfect. So I'm going to take these, plug these back into the original question and see what we get. So absolute value of 5 times a number equals 3 times a number minus 24. Absolute value of 5 times a number equals 3 times that same number minus 24. Over here, I'm going to plug in my 3. Over here, I'm going to plug in my negative 12. I'm going to see what we get. This gives me the absolute value of 15. 3 by 3 gives me 9. The absolute value of 15 is 15. 9 minus 24 is negative 15. I don't know what I was going for there. It's a negative 15. This is not a true statement, so no, that doesn't work. Over here, I get the absolute value of negative 60. Let's see, that's negative 36 minus 24. That's a positive 60 equals a negative 60. That's also not true, which means that for this problem, I get no solutions. Perfect. Okay. And that is how we do extraneous solutions. There you go.